So what we're going to be looking at today would be RhinoCam 2018 for Rhino 6.0. And I'm going to go ahead and start up Rhinoceros 6. As you can see, there is a shortcut on my taskbar for Rhino 6. Rhino 6 runs in Windows. This is the Windows edition of Rhino 6. It's a 64-bit application. So if you have a 64-bit edition of Windows, you can run Rhinoceros 6. And RhinoCam is a fully integrated plugin that runs in Rhino 6. RhinoCam 2018 is our latest version release that is certified to run in Rhinoceros 6.0. We also have RhinoCam 2018 for Rhino 5, but the one for Rhino 6 is the one that we announced recently is the RhinoCam 2018 in Rhino 6. So the older versions of RhinoCam are only compatible in Rhino 5, and we only offer RhinoCam 2018 at this moment. So,
okay, can I ask you to wait just a second?
Sure. Okay, so I have Rhinoceros 6.0 loaded with RhinoCam plugin automatically loaded. So as you start up Rhinoceros, you will also load RhinoCam if RhinoCam plugin is installed. And you'll see that the RhinoCam has a browser-driven interface. So it by default is docked over here on the left pane. And then you have the machining browser where you have two main tabs where you can do your programming. So you have the machine setup, the stock, and then the machining operations. And the simulate is where you can run your cut material simulation or verification. Now you also have the RhinoCam has a machining objects browser where you can define your tools, machining regions. We can also do feature-based machining for like prismatic parts. And we have knowledge bases where you can save your operation workflow and then automatically load those operations on similar type of parts or projects that you're working on. So without any further delay, what I'm going to do here is go ahead and load the part that you had emailed us, the files for the demo. Now I do have two files from you. One is a STL file and the other one is a DWG. So would you like me to start with the STL file first for the demonstration?
Yes.
Okay, great. So there's several different ways how you can open a file in Rhino. You can do a file open or file import, or I could even do a simple drag and drop from your file explorer into Rhino right on top of the viewport, and you can choose to open the file. So you'll now be prompted here, what units would you like to bring it in? I'm just going to pick inches. Is that the right units the part was created in?
Yes.
Okay, great. So I'm going to go ahead and maximize the view, and I'll go ahead and click on the shaded display so you can actually look at the part. So it looks like the part is inverted. Is that correct?
Yes.
Okay. So we could go ahead and rotate the part. You can use the tools that are available to you in Rhino to flip the part over, or you could even use the Orient Part feature that you can find under the Program tab, and you can choose the Oriented so you can flip the direction over. I can put the Z-axis to be, underneath to the bottom face, so it'll automatically rotate the part over as well. So that's one of the ways how you can rotate it. Or if you prefer using the tools in Rhino, you can just select the part, and then they have a graphical gumball in here, which is available in version 5 and 6 in Rhino. And you can pick this and say you want to rotate it by 180 degrees. Press enter. It actually flips the part over for you.
Can you show us the other way where you just flip the Z-axis?
Absolutely. So what we do is when we do a orient part, and then I pick the Z-axis to be pointing down here, and when I accept it, pick OK, RhinoCam will automatically reorient the part to make sure that the part is oriented, normal to the world Z-axis.
It sounds like that would be a more accurate way of doing it.
Both ways are, would work the same way for you. Both give you the same result, the end result.
Yeah.
You can also pick when you have an orient part, you can even pick a face if it's not in one of the orientations, like a 90-degree, or if you don't know what the orientation angle is, you can even use select the surface and pick a face, and it'll establish the normals based on that, and then help you reorient the part. So there are several different ways how you can orient the part to be able to fit the envelope of your machine tool and the correct orientation from which you want to machine it.
Okay.
Okay. Now the part is oriented, rotated correctly, so you're looking down from the top, and you can see all of these 3D features on it. Now, depending on the extent of the part that you have in here. So if I go ahead and analyze the stock extents, it shows it's 96 by 48, which tells me that the length, which is the distance on the x-axis, is 96, and the width is the distance on the y-axis is 48 inches. Now, does your router have more travel on the y or more travel on the x-axis?
It has to be rotated 90 degrees.
Okay, so if you want to rotate it, again, you can use the tool here called Orient Part, and I can say I want to rotate it by 90 degrees. I can say I want to rotate about the Z by 90 degrees, and I can accept that. So you'll notice that the part will be rotated by 90 degrees, yep. Or you can use the Rhino's gumball or transformation tools by using the tools in the transform menu to rotate the part. So we now have the part oriented the way you would like it to be. So I can go back to the box stock, and when I pick copy model box, you will notice that the length, which is the distance on the X, is 48 inches, and the width is 96 inches. Yes. And then you can specify the height or the thickness of the stock material that you'd like to start with. Would this be about 3 inches or?
3 inches, yes.
3 inches. I'm going to input the height as 3 inches, accept it. So the stock is now defined. You can click on Show Stock Visibility, so you can see that both the part and the stock are visible. And you'll also notice that when you specify 3 inches, you can see there's a little bit of additional material on the top. Yeah. Okay? Now, once you have your stock defined, the next step you want to make sure is you want to align the stock to the part. So you can pick Align Stock, and you want to determine if you want the stock to be flushed, the bottom face of the stock to be flushed to the bottom face of the part, or you want it to be at the top and leave additional material towards the bottom, so you can determine how you want the stock to be aligned about the part. So if I choose the bottom, okay, that's what you want to do, and then the XY is centered. So if you had a stock that was 5 by 10 instead of being 4 by 8, then picking one of these corners would allow you to position the stock in relation to the part. In this particular case, since the extents of the part and the stock are exactly the same, you wouldn't have to do an XY alignment. Okay.
Center's fine.
Okay. So the next step is you want to establish your location where you want to put your XYZ 0. Would you prefer zeroing it out to the top of your material and one of the corners, or would you prefer putting it to the bottom in the Z and then one of the corners?
The bottom. So right there.
All right. And then what we would do here.
The northwest corner has to be at 0 and -12.
Okay. So the northwest corner is basically this particular, the upper left corner is the northwest, and you want that to be at 0, 0 or 0 and -12?
0 and -12.
Okay. So what you could do here is you could go ahead and create a point in here and then move it. So I'm going to show you how we can accomplish that. So first step is we want to do set world coordinates. We're going to pick set to stock, lowest Z, and the northwest corner. So this is going to transform the part and the stock over to the origin in Rhino. So right now your 0, 0, 0 is being set to the northwest corner and to the bottom of the stock, but you want it to be offset by 12 inches, right?
Correct. In the y-axis.
Okay, we can certainly do that. So let's go back in here. And you said this corner has to be at -12, is that correct?
Correct.
Okay, so you could do a transform move in Rhino to change the position of it. So I can basically select everything in here, and I could move this in Y by -12. So I can use the graphical manipulator in here, and I can type in -12 for the Y. So it basically shifts the part down by 12 inches. All right?
Did your stock say?
The stock is not aligned, so I need to go back and realign the stock to the bottom. So now you will notice that your 0, 0, 0 is over here, but then your part and the stock are offset from the origin by 12 inches in the Y coordinate axis.
That's right.
Okay, so now when I hit save to save this work in Rhino, all of the steps that you did for the CAD and the CAM programming are automatically saved. So when you reopen this part, you don't have to go through these steps again.
Cool.
All right, so the next step is you want to go ahead and define your workflow of programming this part, and also you can pick the material that you're going to be using it. So what would be the typical material you're going to be working, like a foam or plastic or wood or?
It's foam.
Foam, okay. So you can actually add different materials to a list. You can customize the library of materials. You can also bring in a texture file to map to it. So I can pick something closest to foam. It could be like a soft wood, or you could choose plastic or acrylic, something that would be closer in terms of the material hardness and stuff like that. So you can define it, and this can be used for helping you in computation and determining feet and speeds in here. And there's a XML file in the product install directory which you can go ahead and customize so that you can have your own materials built into the list. Now the materials also helps you establishing feet and speeds. So you can define tools under each tool type. We have ball and mills, flat end mills, corner radius. We have tools for different tool types in here, like engraving tools, V-mills, chamfer mills, taper mills, all the drill tools. All of these tool types can be defined, and you can basically save those tools into your library. All right, so I currently have a library of tools loaded in here, as you can tell, and also feet and speed set. You can always go to load from file, and then you can pick the material, the tool. If you're going to be cutting with carbide, it gives you a recommendation, and you can also set the maximum RPM your machine can handle. Let's say it could be, for example, 30,000 RPM, the spindle. The maximum feed rate your machine can handle, it can put in, like, let's say it's 500 inches per minute. You can set this up right here, and then the system will compute a spindle RPM and a cut feed rate, and you can still set your spindle RPM for each and every tool and operation type. And I could say my spindle RPM, I want to run it at 12,000. It'll recompute your cut feed rate based on the material we selected. You can accept that, and this information automatically gets updated in the tool, and I can save the tool to a library. So the next time I load this tool library, it'll load the feeds and speeds automatically for us. So you don't have to recreate the tools or redefine the feeds and speeds. So this is a very nice productivity feature where you can build your library and have everything saved with it. So I currently have a library of tools loaded in here. You can customize the standard library that comes with the product, or you can build your own libraries as well. Now, the part here, I can see here, since it has sculpted surfaces, you have working with an STL model, you have these sculpted surfaces, you have these curved surfaces. You typically program this using a 3-axis operation. Now, would you typically want to do like a roughing pass and then a finishing pass, or how would you like to go about machining it?
Yes, we want to do a roughing pass, and if possible, we just want to rough around each individual part. We don't want to cut the whole sheet if we don't have to.
Okay. All right. We can certainly help you with that. So, the benefit of working in Rhino gives you a lot of different tools in the CAD itself. So one of the ways I would probably recommend is I'm going to go into those layers in Rhino and insert a new layer. And I can pick a different color for the layer if I'd like to. So I can say I want to specify a different color. I'll just pick a red for now. Now, Rhino has a very nice tool where you can automatically create like an outline around each of these parts. They have a command called mesh outline. So I could even hide the exterior that you have and run this command called mesh outline. And you can find it under curve from objects. And you'll see this command called mesh outline. So when you pick mesh outline, it'll ask you to select surfaces, polysurfaces, and meshes. I can just drag a window to select all of these and then press enter. So this automatically creates a boundary around each of these parts, as you can see right there.
That's very quick.
Yep. Now, I can also do something really nice here. I can go ahead and put a little offset in here around each of these. I'm going to pick a different color for the layer, added a new layer. So this will give you enough room for the cutter to completely go past, but you can use these geometries to do a profile cut around it with an end mill, so you get a nice, sharp edge, as opposed to just doing a finishing with a ball mill and then leaving the radius around the cutter. So one of the things you can do is you can create an offset in here. So you can use curve, and then you can use the offset command and use the offset curve. So depending on what size cutter you're going to be using, if you're going to be using a 1/2 inch or 3/4, what would be a typical tool diameter that you plan to use for these parts?
1/2 inch.
1/2 inch. So what I could do here is set my distance in here. So go maybe slightly past the cutter radius, so you get a nice little overlap. So I'm going to put in like 300 thousandths. And what I can do is select the curves to offset. I can just offset this curve towards the outside. I can just repeat the same step for each of these, as you see right there. You can even script it in Rhino to go ahead and, run this command repeatedly multiple times, so you don't have to manually do it for each and every part in here, right? So all I'm doing is selecting it, pressing enter to repeat the previous command, and I'm able to quickly offset these boundaries in here. So this gives me a nice, area around the part, so I can get all the way down on the sides to be able to machine the part to the floor. So I'm just defining a boundary in here and offsetting the boundary by 300 thousandths as you see it right there. Would you have any questions so far?
Just 0.3 so that's over half the diameter.
Right.
Yeah.
So
I just went past half the diameter, so that way it gives a nice, cuts all the way down on the sides. So just to give it enough room. And you can see that.
Is that offset going to become, well, what are you going to use the offset for? Is that going to be the center of the tool cut or what?
Yes, the tip of the tool will stay up to the boundary that you pick.
Okay.
Okay. Now, also I can create an outline around this rectangular sheet as well. Use the same command, the mesh outline command. I can create that mesh outline command in here too. I can put it on the same layer. So it creates a boundary around the 4x8 sheet as you have it right here. Now, the first step here is we want to go ahead and do a roughing and then a finishing operation, or would you just want to do a finishing operation since you're cutting just foam?
So we want to do rough and finish. Rough with a 1/2 inch and finish with a 1/4.
Okay. So would you want to use a flat end mill for roughing, or would you want to use a ball mill for roughing?
Ball.
Okay. So what we'll do is
for roughing we use a flat line.
Okay.
And for
so
finishing we use a ball.
All right. We'll go into 3-axis. We'll pick horizontal roughing. And then over here, if you want to contain the tool paths just to these areas in here, we can use select curve edge regions in here. And now I can actually go ahead and select objects by layer, right-click on this layer and say select objects. It'll automatically pick all of the boundaries that we created, so I don't have to go and individually select each and every boundary. So I can do a select by layer.
Can you undo that? Because we had your go-to meeting box right over what you were doing on the right-hand side of our screen.
Okay, I'm going to pull this over here so that way you can see it better.
I've moved the meeting box as well, so we can see the whole screen now.
Okay, all right, great. So I'm going to go over to 3-axis and pick horizontal roughing. And I'm going to pick select curve edge regions. And it prompts you to select either curves or surface edges. Since we are working with an STL model, like a mesh geometry, there aren't any surfaces or surface edges, so we can pick curves as boundaries in here. I'm going to right-click on the layer that we created these curves, and then I'm going to choose Select Objects. So it automatically highlights or selects all of the curves that we created, and you can notice that we had this nice little offset put around it. So once I have these selected in here, I can press Enter or right-click. You can see it prompts you there. Select Objects, press Enter when done. So I can either press Enter, or I can do a right-click. So all of the boundaries are selected, so we have a total of 27 boundaries around the part.
That's cool.
Okay? And then I go to my tool, and then I make a selection for the tool. So I have a 1/2 inch flat mill selected. You notice that we put in the feet and speeds earlier. So we'll just go with that right there. We pick the tool. The feet and speeds are being loaded from the tool. You can define your clearance in here. You can specify the clearance to be automatic, so the system will automatically compute the safe height based on the part and the stock material to clear the stock. And then you can put in your cutting parameters in here. You can specify, how do you want to cut it? You can say, choose the different types of cut patterns. You can use different patterns for cavity and core regions. You can choose the cut pattern in here. You can specify your step overs. You can also specify the cut levels, how fine you want the cutter to step in the Z. You can also specify engage and retracts, any advanced cut parameters. You can put in all these parameters and then click generate. So in this process, it takes into account your part, your stock, and automatically computes a 3-axis roughing toolpath. So it's computing it based on the part and the stock. So while this roughing is being computed, I can also go ahead and generate a finishing pass. We could start with a
Before you go on to the finishing pass, did you specify an amount that it would leave above the geometry so that you can take that last quarter-inch off with a finishing pass?
Yes, the default was 25 thousandths to leave, so it'll leave a minimum of 25 thousandths above the part.
If you can change it.
Okay, but you can change it. That was one of the things you could edit?
Absolutely. All the parameters can be set by the user or the programmer. So the default value was 25 thousandths. It'll leave a minimum of 25 thousandths, but you can change that to even an 1/8 inch or whatever you want to leave it. So you can see that the roughing just got completed right there. And, you know, right over here in the cutting parameters tab, you see the start to leave. So it'll leave a minimum of 25 thousandths.
Okay.
All right. Now let's go ahead and take a look at a verification in here. So the roughing toolpath was completed. I'm going to go into the Simulate tab, and I can select the operation, hit the play button, and that gives you a quick verification in here. As you can see, you can even slow it down in here in the simulation. You can have it go faster or slower. You can set each of those parameters for it. And you can always select the pause button and then pick Simulate to end. It'll run through the simulation for you. So as you can tell here, it is not cutting in these open spaces since we picked a region. So you're basically making the most effective, efficient use of your material and not turning everything into chips, right?
Right. That's great.
That's what we're doing now.
So I'm just running the simulation to end. Here you can see it's running through each of these go-to motions in the simulation, as you can see it right there. You could also change and apply different colors in the simulation. So you can specify a certain color for roughing versus a certain color for finishing in the simulation. So it just makes it easier for you to view it. So if I go ahead and change the color in here, I can go to Operation, go to Properties. I can pick a color. I could say I would like to apply the darker yellow color for the roughing. So now you'll notice that the roughing, after the roughing is completed, when you simulate it, it shows up in a different color simulation. So the uncut material is left in kind of the golden color or light orange color here, and the cut material is in the color we just picked. So now I'm going to go back to the Program tab, and I can go from a roughing to a finishing. There's different ways we can finish it. In our standard configuration, we have, in addition to roughing, you have parallel finishing, horizontal finishing, radial and spiral machining. Our Pro offers all of these advanced 3-axis methods. Now, parallel finishing is also known as similar to planar finishing, so where you can basically raster it back and forth. Again, you can do selection here. There's different ways to select regions. I could do select curve edge regions, and in this particular step, I'm going to show how we can use the select by a certain color. I can say select by a certain color, and I can just go ahead and pick this curve that's green in color, and when I right-click, it'll automatically select all the objects that are of a certain color. So you notice that you can use select by layer, or I can use select by color. There's different selection techniques that you can apply. And now we want to go to the tool. We want to swap this out with a ball mill. You said you want to do a 1/4 inch, so I'm going to pick that tool, and I can go ahead and apply my feeds and speeds in here. I can set my feeds and speeds. Again, I can pick my tool type, and I can set my maximum RPM here. And I can change my spindle RPM for cutting. I could say I want to go at 15,000 RPM for finishing and cut it at maybe 300 inches per minute. Accept that. Save my edits to the tool. And the tool is now updated with the changes that we put in here. When you go to feeds and speeds, you'll see that it automatically loads them from the tool. When you hit the load from tool, you can set your clearance to be automatic. Very similar workflow. Now you can see that the stock set is set to 0. If you want to do it as a pre-finishing pass, you can leave some stock. You can say you want to leave like 10,000 stock and then go back and add another finishing pass to clean it up. Or you can just go from a rough to finish by setting the stock to 0. You can choose your cutting direction here. You can do mixed, or you can do climb or conventional. You can also set the angle of cut, which is the direction of cut. Basically, if you set the angle of cut to 0, it would traverse back and forth parallel to the x-axis. If you put in 90, it'll traverse parallel to the y, or you can put in any angle. You can say even 45, for example. You can specify any angle that you prefer in here for the cut angle of cut. And you can choose your step over, how fine you want the cutter to step. You can use a percent tool diameter, distance, or even a scallop height. I could say I want to do 15% of the tool diameter. You can also do additional parameters here. You can sort them, go with a minimum distance in here to reduce the number of transfers, and pick generate. So in this particular process, it's going to compute your finishing tool path. So it's computing the parallel finishing tool path. Now, while it's computing, you can still rotate the view. You can add a new operation if you need it. It's using what is called a multi-threading manager, so the tool path is being computed. You can generate multiple tool paths at the same time. So we just got the tool path generated. I'm going to hit save to save the work. So the Rhino file is automatically saved with all of the information. And I'm going to display the tool path in here. You can see that the tool path is following the model right there.
Very cool.
And since we picked a containment here, you can see it's flowing nicely to the surface in here, right?
Yeah.
Okay, so now I'm going to run a verification in here.
I'm sure this is possible, but just to play it out, if we had a sheet that didn't have that bottom layer flat and it was just the parts, you can tell the cutter to stop like 15 thousandths above 0, and it'll just stop there, right?
Absolutely. So if you go into your parallel finishing, one of the options you have is called a Z containment, and you can specify your lowest Z and the highest Z. So if you put in a lowest Z, and you can even do a pick, and you can pick a point, or you can specify to stop a certain height, not go all the way down to the origin. You can put it in here.
Right. Great.
Okay. So if you have a plane, then that eliminates the step for you to do it, since you already have put in here.
Sure.
So now I'm going to hit simulate here, and you can see that it is performing the material removal. And I left it to the default color of the simulation here. As you can tell, it is removing the material that was left from the previous step. And we're going to parallel to the x-axis. It's going, the angle of cut is set to 0.
Mm-hmm. It looks like, based upon the tool holder, we might have a conflict between the tool holder and the part.
You're right. If there is going to be a holder collision, it's going to mark those areas during the simulation in red. So in this particular case, my tool holder tool length is set to 4 inches. So your part of stock is only 3 inches. I think we should be okay here. But if your tool length was just defined as 2.5 inches, then you would have definitely noticed a holder collision in here.
Okay.
And I
so
can.
How would you do that?
So either you want to clear this material out first.
Yeah.
Right? So we could do an operation called facing. In one pass, we can clear it out. So after the roughing is completed in here, I could add a tool path called 2-axis and facing. So I could use 2-axis facing in here to remove all of this material in just one pass. Or you can do, so basically it'll clear them out. So you can go ahead and select all of these edge curves, and I can say select based on a color. And I'm going to pick this right here, the red color. And it picks all of these boundaries in here. So I would like it to clean it up right up to this edge. I can use a facing operation. I can use the same 1/2 inch tool with the same parameters I used earlier. And I'm going to say clean up around these areas too. And in the cut levels, you could say how deep you want it to cut. And I can stop it right up to this level here where you have the vertex on this particular model. So I can say I only want to go down to that level, just take it out in one pass. I can do a generate here. It's going to actually create a facing operation, which basically, clears the material past the exterior edge. It treats the exterior most extent what you pick, the boundary what you picked as the stock extents, and then it'll treat all the inside areas as islands. It'll let you clear all the material in between these two. And you can just take it out in one pass. So that's a very efficient way to remove excessive material. You don't have to go through in multiple steps if the material that you're cutting is not very hard. And then once you've done that, you could go ahead and run the parallel finishing operation. And I'm going to show that to you here in just a moment. So it's generating your facing tool path in here. And once the facing tool path is completed, we can go ahead and run simulate the parallel finishing operation. Do you have any questions so far?
Let me ask you a question. We have a situation where on some of our parts, the part is so steep that with the tools that we have, we can't get all the way down without the cutter hitting the part itself, or the tool holder hitting the part. So we have to program in a 2-inch block to keep the cutter from going down below that area. Is there something in your software where if we have a collision area, it will stop at that level and not go on down? Or will it only just indicate that you have a collision?
Well, it'll indicate and it'll mark those collision areas for you. It is not going to stop it. You would have to specify like a Z containment to stop it. You can separate them into different areas, and then you can say on these areas you don't want to cut past 2 inches, or you want to leave 2 inches from the floor. So you can basically break them up into different areas.
But you would have to pick those areas yourself, right?
That is correct. So over here, I did a facing operation, so I'm going to do a simulate. As you can tell here, I'm just using the same 1/2 inch cutter to basically clear out the material around the roughed areas in just 1 step, or I can do it in 2 steps if necessary. Right?
Yes.
Right.
If you needed to do that to relieve the material around it, so it makes it easier for the finishing process, you could do that. And then on the finishing process in here, I can apply a different color for the simulation, so just it makes it easier for us to view it. So there's the finishing pass, running a parallel finishing operation. You can always speed up the simulation in here. And you can also choose pause and then hit the simulate to end button, so that actually goes through the simulation all the way to the end. Do you have any questions so far while it's simulating?
I don't.
No. Looking good so far.
So there's a couple of things I'm going to show you here once the simulation, we get through the simulation. Since there's a lot of toolpaths in here, you can see it's going over, it's over 1 million go-to motions, as you can see right there. 1,087,000 or 1,090,000 toolpath motions. So you can see it's able to handle and process such large data sets and, work with it very well. So now what you could do is when you have parts that are very similar to these that would require a similar type of workflow, a similar type of operations, you could save all of these operations that you programmed into what is called a knowledge base. So the knowledge base allows you to save the entire workflow of machining operations, which includes the cutting conditions that you put in, the depths that you put in, the feet and speeds that you put in. All of that can be saved. So it looks like the simulation was just completed right here. You can see right there. Those are the simulations of the finished parts.
Yeah.
Okay, now let's go back to the Program tab in here. And if you save your work, it automatically saves all of these operations. Now we can save the entire workflow of machining operations to a knowledge base. So this saves the workflow, the cutting conditions, the parameters that you put in, your feet and speeds, the tool, all of it. You can save it to a knowledge base. And when you have parts that are similar to this, you can load those knowledge bases as well. So I'm just going to go ahead and save this in here. So it is saved. And then when you have another project that requires similar type of machining, you could load the knowledge base, and then all you have to do is select the machining geometries for it. Now, there's one step further we can go, is we can also automate the selection of machining geometries. So we can apply what is called selection rules, and you can automatically say for the parallel finishing, select all the objects that are in a certain layer or certain color. So we can apply rules by going to this knowledge bases tab in here. I'm going to load this knowledge base, and I could say for the horizontal roughing, I would like to automatically select all objects that are on a certain layer. For the facing, I could choose to automatically select all the objects that are on layer 1. right? You can see how easily you can establish these rules. And then you can see that you already have the layers created in here. So you can specify the objects. You can basically go back and say you want to pick objects on a certain layer. So it's very easy to go ahead and specify these rules in here. And finally, for the parallel finishing, we want to use the same set of regions that we used for what we used on the roughing operation, layer 3. So you can establish rules, and then once you save this back to a knowledge base in here, when you load the knowledge base, it'll automatically have the regions selected, pre-selected. So all you have to do is regenerate the toolpath, and I'm going to show you how that works. Now, we got all of these operations programmed in here. You can select the machining job, and then you can do a right-click and take a look at the total machining time on how long it's going to take to cut it based on the parameters and the feet and speeds we put in here. So you can notice that the finishing operation, we're running it at 300 inches per minute with a very fine step over. That's the one that's taking a long time. So you can optimize that. Also, you can optimize your roughing operation, which says about 11 hours, but you can optimize it to take much deeper cuts, because in the roughing, we're specifying it to use only 50% step down. So you can optimize it further to basically take a deeper cut. And also you can increase the step over from 25%. You can say you want to go like 40% or 50%. So you can optimize it so you can make your toolpaths more efficient. So I could say I want to change this to 50% cut levels. I can change this to 100% of the tool diameter, or I can even specify a distance in here. So I could say each pass I want to take out 3/4 of an inch. And then I pick generate. So you can optimize the toolpath. Sorry, go ahead, sir.
I was going to give you the parameters to put in there, but you've already gone past that.
Okay, I can go back and edit it and then re-enter the parameters for you. And all of this information can again be saved to the knowledge base, so you don't have to go back and re-enter it each time. So that's the beauty of knowledge bases. It saves you, repetitive work and makes it more efficient.
Yeah.
So now for what I put in here, the roughing operation is down to 2 hours.
Yeah, that sounds like a big time saver.
Mm-hmm. So, yeah, go ahead and provide me the parameters that you were talking about for the roughing.
Okay, on the, we want to leave the 1/4 inch stock. Instead of 25 thousandths, we want to leave a 1/4 inch.
You want to leave a 1/4 inch of material on top of it, okay?
Right. We want to step down a 1/2 inch.
Okay.
And step over 40 thousandths or 400 thousandths.
Okay.
Yeah.
And I can also use a different cut pattern. Like, for example, if you want to do a linear cut pattern, you can do a linear pattern if it's going to make it faster for you. You can use a linear cutting pattern in here as well. You can do that.
Will that be faster?
In cases, depending on the geometry, yes, it could be. Or you can even do offset. So, you can set each of these parameters in here and see, what works best for you. And once you define it, all you have to do is regenerate the toolpath. And how about on the finishing pass? What would you like to use for the step overs?
1/8 of an inch.
Okay.
125, 125.
All right. So I'm going to go ahead and that would be like a 50% step over. Is that right?
Yes.
Okay. Now, are you going to be doing any sanding or anything past you do a finishing on the CNC?
No. It'll be just the 2 cuts is all we take.
Okay. So I can go ahead and select the operation in here and then right-click and do an edit on it. And I can modify the parallel finishing operation here. So go back and do an edit, go to cut parameters, and I can change the step over in here to 50%. Or I can even put in a distance in here. Okay, and then generate. We'll recompute the toolpath. Now let me go back and do the update it, for the facing as well here. So I'm going to put in a step over of 50%. I can do edit. I can go back to the tab here. I can specify it to be 0.4, which is 400 thousandths. And now if I can go back and check the estimated time, and you'll notice that it's going to be a lot more faster. Okay, let's look at the machining time information. You'll notice that it's down to a little over 2 hours, and then you have your facing, and then the parallel finishing in here. So if you take a look at the toolpath, there's your horizontal roughing operation. And I could always do a pause delay and to run through that. Then go back and run the facing operation. Then do the parallel finishing operation finally here.
That's basically what we do. We do a contour on the rough parallel.
And then we can finally do a profile to cut around each of those parts, like a 2D profiling.
Do you have tabs or bridges that you can put in if we would cut these parts out that would keep them from dropping down to the bottom?
Absolutely. We could do that in profiling. So I'm going to go back in here, and I'm going to add a profiling operation, 2-axis profiling. And I'll now go ahead and select the profiles in here. So I'm going to go to select the geometries, and I can do select by layer or select by color. I can say select objects by color. And I can drop the outermost boundary in here from being selected. And then I'll grab a tool for the profiling. So typically you want to use like an end mill.
Yes.
I could do a flat end mill, 1/2 inch. Set the feeds and speeds and clearance. You can set your cutting parameters. You could choose to cut on the outside. And in the cut levels, you can specify how deep you want it to cut. So do you want it to just go down to 0, or would you want it to leave this thickness above it?
Minus 5,000.
You want to go past the 0 to 5,000. Okay, so we could set the location of geometry here. We could specify, you want to start at 3 inches, but then you want to go down 5,000. So I could say 3.05, or, I put in 50,000. Okay, so I can specify that. I can do it in 1 or 2 steps, and then I can specify entry and exit if I need it. Okay, here in the advanced cut parameters, you could specify your bridges and tabs. You could do triangular bridges, or you could do rectangular bridges. You can specify the bridge height in here, and then the bridge length. I could put in maybe 1/2 inch or 3/4 inch, and you can specify the total number of bridges you'd like to see on each of these parts. I'm going to put in 4 on each. And again, I can sort the sequence in which the profiles are being cut and generate it. So this would give us a profiling operation. And I'm going to show you, preview the bridges and tabs in here. As you can tell, it automatically creates those bridges around each of these areas. So
that's pretty cool.
Yep. And if you want to
That
put
was cool.
Can you grab those bridges? Can you grab those bridges and move them?
Absolutely. What you could do here is we have a very nice feature called predefined regions, and I'm going to show you how that works. So let me go ahead and hide these geometries in here. I'm just going to keep these areas with. So we'll go to this tab called regions, and I'm going to select just a couple of them to give you an example here. So I'm going to pick these 2 in here, and they both are defined as predefined machining regions. Now I can go ahead and click on automatic bridge points and specify the number of bridge points, place 4. I'm going to repeat the same for these as well. So I've defined 4 bridge points on each of these curves. Now I can edit the bridge points in here, so I can double click to edit, and I can drag and drop the bridge points over. So wherever I want the bridge points to be placed along the curve. So I can move the bridge points around right here. So you can define bridge points for each of these, and then right click. Now once you define the bridge points, I'm going to go ahead and program a profiling operation in here. Rather than selecting the curves directly from Rhino's viewport, I'm going to use a predefined region and select the two. I have these two selected in here. Now I'm going to generate the toolpath, and you'll notice that it creates those bridges and uses the bridge points at the midpoint for the bridges and exactly where you specified them. So to run a simulation in here, you can run a simulation just right after the facing. You will notice that it creates those bridges and tabs. At the exact location where you specified those. Does it help?
Yes.
Okay.
That's fantastic.
So, thank you. Now, once we have all of these generated in here, like I pointed out, we can save these to a knowledge base. And we can specify a name for the knowledge base. And we can also automate them by specifying rules for the knowledge base as well. So we programmed this entire part. Let's look at the time in here. I'm going to go to information. It gives you the machining time. And you can also post-process this out to your machine tool now. You can select the post-processor. Would you happen to know the post-processor that you'd be using in here?
Yes, Techno.
Techno, okay. So I'm going to go down the list here. I have the Techno CNC post. If you have the new one, HT2, we can also provide you a post for that.
Yeah, that's fine.
Then we specify the extension. It could be NC or NCD, whatever is the preferred extension for your CNC.
NCD.
Okay.
NCD.
So the NCD. And now I do a post in here, right-click and post, and specify a folder where you want the posted file to be saved under. Automatically, it'll grab the name of the file that you saved under. Or if you want to rename the file to something else, you can give it a name. And once it's posted, it'll automatically appear in a text editor. It could be like a notepad, or you can choose your own viewer to display the code. So the G code is now output and displayed right up on your screen. And you can see the tool numbers are being called as well. And the program is now ready to be transferred out to your machine tool.
I've edited it already on mine. Edit.
All right.
Any questions so far?
I don't have any more for this. Can we look at the other part?
Absolutely. So now let's talk about the knowledge bases, right? We were looking at earlier, so I'm just going to go ahead and delete these operations that I programmed in here. And let me go back and reopen this part, the one that we programmed just now. And let's consider that there weren't any machining operations on this particular part, right? So if you already defined the knowledge bases with the rules on it, I'm going to load the knowledge base. You'll notice that the roughing operation, the 3 operations that we had programmed were already there. And when I pick on the roughing operation, you can see that based on the rules that we put in, it automatically pre-selected those regions. So we had set up a rule to automatically select for roughing all the objects that are on layer 3. And for facing operation, we had set it to select all the objects on layer 2. And for parallel finishing, all objects on layer 3. So based on the selection rules that we put in, it selected them automatically. So all I have to do is right-click and regenerate, and the toolpaths are generated after you established your stock. That's all you got to do. That's how easy it is to program it. So you can set up your workflow templates and save them into a knowledge base. So it just makes your programming a breeze. Okay?
Yes.
All right. Now let's go ahead and take a look at the other file.